So this is the initial part of filling out practice 3 in our waves packet. And what we want to do is take a look at what we have written, right? So we have a student with 20 meters, not centimeters. So take a look at the units. 20-meter string in which waves are traveling at 10 meters per second. So this is going to be our velocity. And this is the length of the string. And so we're going to do this first one, the fourth one, and then we're going to look at this last one as well. So we have to draw a standing wave that has 3 antinodes. And so if you remember, the antinodes are the parts of the standing wave that's the furthest away from the midline. So let's draw our string as actually, I'm going to draw it as a dotted line to show kind of like our midline. Okay, so our string, which is 20 meters long, and we are going to draw the 3 antinodes now. So I'm going to draw it in a different color. We have 1, 2, 3. Okay, so this is the node, this is a node, this is a node, and this is a node. And the points that are furthest away from the midline, that's our antinode. Okay, antinode, antinode. Now, the wavelength, so the length of, I'll draw it in blue. So from here to here, that's the length, is going to be 20 divided by 3 because there are 3 of them. So the length of one is going to be about 6.7. So the length of one harmonic is about 6.7 meters. And the wavelength is 2 of the length of harmonics. So 2 times 6.7 meters is going to be 13.4 meters. Now the frequency, we can use the equation velocity over wavelength. So we have the wavelength, which is 13.4, and our velocity is 10 meters per second. Okay, so velocity and wave speed, remember, it's referring to the same thing. So 10 meters per second, and you can fill that in for this whole box because the string doesn't change. Okay, so anyway, here we go. So the frequency is going to be our velocity of 10 meters per second over our wavelength of 13.4 meters. Okay, and so we have 10 meters per second over 13.4 is going to give us about 0.75 hertz. Correct. So our frequency is 0.75 hertz, our velocity is 10 meters per second, and our wavelength is 13.4 meters. Okay. And so that's for row 1. Now skipping down to row 4, this time they don't tell us what harmonic it is. They do give us the frequency. So that means that we can probably solve for the wavelength. So we'll just have to work backwards. All right, and so we have our wavelength is equal to our velocity over frequency, which we know is 10 meters per second over our frequency of 1.5 hertz. And so when we do 10 meters per second over 1.5 hertz, and so you go 10 divided by 1.5. So when you put in the calculator, it's 10 divided by 1.5. You're going to get about 6.7 meters. So that means the wavelength is, so that's 2, let's see, Now remember, that's 2 times the length of one harmonic. So one harmonic is going to be half of that. So this is actually 2 footballs like we talked about. Okay. So if you notice, this is 13.4, 6.7 meters, 0.75, 1.5 hertz. So this number, 1.5, is twice that. And this number, 6.7 meters, is half as much as that. So that means that this whole thing is going to be two wavelengths. So we're going to end up with 6. Okay. So we have our initial line. Remember that that's 20 meters. And each one is going to be each wavelength is going to be 6.7 meters long. So then that means that there are 6 harmonics. So this is the 6th harmonic. And so you can label all the nodes and the antinodes. And so remember that that makes up one whole wavelength. All right, now lowest possible frequency. This is the fundamental frequency that we talked about. Okay, and if you could take a look at the slides for this class, you're going to find out that this is the lowest possible frequency of that note that we're talking about. So that means that there's going to be one standing, or just one harmonic. And this one harmonic takes up the whole string. Okay, so it takes up the whole string, which is 20 meters long. So that's the length of one harmonic. And our wavelength is equal to 2 times the length of one harmonic. So our wavelength is 2 times 20 meters. Our wavelength is going to give us 40 meters. And our velocity didn't change. And our frequency is still velocity over wavelength. So we have 10 meters per second over 40 meters. So 10 over 40, or 1 over 4, is going to give us 0.25 hertz. And then going back to check your work, you can see that this should be, so this is for the 6th harmonic, then this should be 0.25 times 6. Okay, this is from the Standing Waves lab that we just finished. So you have the frequency is equal to your fundamental frequency times the number of harmonics. All right, and if you have any questions, as always, please make sure to email me.